Okay, guys, so yeah, this is our Instagram page. This is our math project. It is on YouTube, obviously. You can look us up on Instagram or on YouTube if you need a second look at our page. We'll be starting off with a few videos that we made at school.
Using graphs and functions in your everyday life can help you solve certain areas of your occupation.
The use of graphic can be used in your favor and even others.
When doing analysis of any kind, we need to make use of structure. This can be done by using a graph.
Graphing is used daily, from stock markets to performance evaluation in companies. Some even use them to boost sales and meet deadlines.
Graphing functions can and very possibly will become a very important aspect of your daily life when you're older, so start paying attention in class today.
So, yeah, this is another post we made. It's about graphing, like when to graph a function, or what it will look like. In the graph below, we have radical functions with different values of a. So this red line, blue line, and green line are all values of a. If a is less than 0, the graph will be a radical x. Is the reflection in the x-axis of the graph? If so, then y will equal the absolute value of a radical x. So this is what will turn out to look like. Another square root equation would be y equals a radical x minus b plus c. In this post, we have more, basically, just explaining it in a little deeper content. A radical, as you might remember, is something that is under a radical sign. A square root, a radical function, contains a radical expression with an independent variable, usually x, in the radicand. Usually radical equations where the radical is a square root is called square root functions. As an example of a radical function would be y equals radical x. This is the parent square root function, and its graph looks like this. If we compare this to the square root function, y equals a radical x, we will notice that the graph stretches or shrinks vertically when we vary a. So yes, we did work on this in class. It's the vertical stretch and the vertical shrink, so I know you guys all can relate to this. To graph a function such as f of x equals y equals 2x plus 7, we can select a table of values, plot, and connect the points. To fill the table, we choose values for x and use the functions to get the values of y as shown in the following table. So yeah, we actually just worked on this. The graph of the data in the table above is linear. The value of y when x is 0 in the function is called the y-intercept, and the value of x is when y is 0 is called the x-intercept. The above graph is a linear function of the form y equals mx plus c, where m is the slope of the straight line and c is the y-intercept. The slope of a straight line passing through 2 points, x1, y1, and x2, y2, is defined as the following. For the graph above, slope equals 2 and the y-intercept equals 7. So yeah, this one is telling you more about graphs. It's A graph is a planned drawing consisting of lines and relating numbers to one another. With the use of color and a little imagination, you can quickly whip up a professional-looking graph in no time at all. With technology at your fingertips, you can make use of the computer. When doing calculations in everyday life, we need the basic knowledge of making use of graphs. It is not just for those that excel in math, but for every student to use according to their needs. When doing analysis of any kind, we need to make use of the structure. This will be done by using a graph. Graphing is used daily, from stockbrokers to performance evaluation on companies. All use them to boost sales and meet deadlines. So this is comparing it to the real world, how you can use graphing in the real world. Functions are mathematical building blocks for designing machines, predicting natural disasters, curing diseases, and understanding world economies. So yes, as you see, we do have building blocks and functions on them. Functions can take input from many variables, but also give the same output unique to that function. Functions also allow us to visualize relationships in terms of the graph, which are much easier to read and interpret than lists of numbers. So yes, we did work on this at the very beginning of the year. Money is a function of time. You can never have more than one amount of money at the same time because you can always add everything to give one total amount. So yes, we do have a big bag of money because that's the total amount. Temperature, as a function of various factors, temperature is a very complicated function because it has so many different inputs, including time of day, the season, the amounts of clouds in the sky, the strength of the wind, where you are, and many more. Location is also a function of time. You can never be in two places at the same time. So again, this is relating it more to the real world. Functions though, not graphs. We use graphics and charts because they help make any data more effective, interesting, and easy to understand and easy to compare. They also help one to present data in a logical and consistent way. Yeah, and then this is our bibliography. So yeah, thanks for listening, and yeah, so thanks for, yeah, see ya.